Good morning. We are doing notes today, so you'll want to get your notebook. This is my third record. Hopefully this is the one. The title of today's notes are Rational and Irrational numbers. We're going to start with rational. And we can see inside rational is the word ratio. And ratios can be written as fraction. Ratios can be written, oh my God, here we go, written as fractions, a fraction. So a rational number this vocab word is important. A rational number is a number that can, and we're going to underline can, or maybe I'm going to box it. Oh, I box it with a fun little something off the side. A rational number is a number that can be written as a fraction where the numerator and denominator are whole numbers. This part where the numerator and the denominator are whole numbers is important to have in there, but it's not so important for you guys to know. It's important to have it in there to be exact, but if you just remember that a rational number is a number that can be written as a fraction, and this is kind of like a qualifier here, the fraction where the numerator and denominator are whole numbers. Okay, I'm going to erase this. So types of rational numbers. If you're asking, is it a rational number? Okay, this is the same question as can it be written as a fraction with whole number? Numerator and denominator. Numerator, blah, 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 and denominator. These are the same questions. Is it a rational number? Can it be written as a fraction? So let's look at whole numbers. Like 5 can be written as a fraction. So whole numbers are rational. Fractions already are written as a fraction, so fractions are rational. How about whole numbers? How about negative whole numbers? which are called integers, like -6, can be written as a fraction, -6/1. So that's rational. Terminating decimals. Can be written as a fraction, like 0.25 that's in the hundredths place. So this is 25/100. We don't even have to reduce it to see that it is a fraction of whole numbers. So terminating decimals are rational. Am I writing under my head yet? And then repeating decimals. I'm running out of room here. Like 0.2 repeating, we saw, is 2/9. Can be written as a fraction. Are rational. I have to erase this. So you may want to pause. I'm just going to relist the, I guess I won't relist it. The last kind of rational number, square root of perfect squares. The last kind we're talking about. So like square root of 25 is 5, and it can be written as a fraction. So they are rational. So those are your rational numbers. So I'm going to erase, and then we're going to talk about irrational numbers. I think the prefix IR means not. Hold on, I'm going to pause and research that. Okay, yes, I was correct about that. So the prefix IR means not. So irrational numbers are numbers that are not rational. And if rational numbers can be written as a fraction, if that's what makes a number rational, an irrational number are numbers that cannot be written as a fraction. And these numbers are non-repeating and at the same time non-terminating decimals. Non-repeating means there's no repeating pattern. And non-terminating means it never ends. The most famous irrational number is pi. The decimal approximation, I should say a decimal approximation of pi is, oh gosh, hang on, there we go, sorry. A decimal approximation of pi is about, wiggly equal sign means about 3.14 926. And then I'm going to go dot, dot, dot. And the dot, dot, dot says, can you guys see that? I hope my head's not over that. I'm going to erase and write this at the top, just in case my head's over that. Erasing now. So where were we? We had pi is about equal to 3.1415926 dot, dot, dot. And that dot, dot, dot means and more. Or and infinitely more. Okay. So, yes, some digits repeat. We have a 1 here, and we have a 1 here. We're going to have more, all of the digits are going to repeat, but it never ends. And it never has a repeating pattern. It never settles into a repeating pattern. Okay, and the fancy word for never ends is non-terminating. And never has a repeating pattern is non-repeating. So pi is irrational. I'm going to erase this. Am I? What's going on here? It's not letting me erase. It's not letting me pause either. There we go. Oh my God. All right. So, irrational numbers include, besides pi, any expression with pi, like 2 pi or 3 pi or pi plus 1 or pi over 2. Those are all irrational. Okay, and square roots of non-perfect squares. So, like square root of 2, we saw. Square root of 3. Square root of 4 is rational. Square root of 5 is not. Square root of 6 is not. Square root of 7 is not. Square root of 8 is not. Square root of 9 is rational, and so on. So there you go, rational and irrational. You're going to do some practice on that now. See you guys.